Hi, welcome. Today we are going to take some summary for mathematics for economists. Okay. Yeah. Meaning we are going to be using questions and answers to explain it and summarize everything in bit for you. Okay. So kindly pay attention and take your book, your pen and your calculator so that whatever explanation I'm doing, you are jotting something down, and also you are doing the calculations that we'll be doing as well. Okay, so that you know that yes, you understand. Okay, so pay attention. We are starting. So we are going to take question 1. Question 1 says the demand function for 3 related commodities are as follows. So you are given equation 1, you're given equation 1, equation 2 and equation 3. Okay, now where QDS, QDY and QDZ is sub, okay, QD sub X, QD sub Y and QD sub Z are quantities demanded of commodities X, Y and Z respectively. PS is price of X, PY is price of Y, and PZ is price of Z. And Y is the income of the consumer, like the block capital letter Y is the income of the consumer. Okay, now with brief explanation, okay, meaning everything you answer here, after answering you explain. Okay, A, determine the nature of commodities X in terms of income. B, determine the nature of commodity Y in terms of its own price. So let's do that. Now let's take A first. A says determine the nature of commodity X in terms of income. To do that perfectly, okay, all you are going to do is that it's a commodity X in terms of what? Income. I follow it. So you go to the equation where commodity X is, QDX. I follow it. Now you look at commodity X, quantity demand of commodity X, okay, and look at income at that level. What is the relationship between them? There is a negative relationship between them. I follow it. There is a what? Negative relationship between them. Whenever there is a negative relationship between a particular quantity demand of a particular commodity and the income of the consumer, when there is a negative relationship between them, you say what? It's an inferior good. Hello. Commodity X in terms of income is an what? It's an inferior good. Then you explain. This is because as the income of the consumer falls, the quantity demand increases. I follow it. Yeah. So there is a negative relationship between quantity demand of commodity X and income. So that makes it inferior good. Hello. Now, if another question had asked you, okay, that the relationship between commodity Y and income, you check quantity demand of commodity Y and income. The relationship is positive, so this one is normal good or superior good. Okay, another name for normal good is what? Superior good. So for this commodity Y in terms of income is a superior good or normal good. Then if another question had asked you for commodity Z in terms of income, you would have checked quantity demand of commodity Z and income is negative, so it's inferior, just like the first one. Okay, so that is A. But A is just asking for X in terms of income, so you only answer X in terms of income and go. Okay, I'm just explaining the rest so that you know. Now let's go to B. B says determine the nature of commodity Y in terms of its own price. Determine the nature of commodity Y in terms of its own price. To do that, kindly pay attention. To do this, I follow it. You look at commodity Y. Have you seen that? Look at commodity Y and look at its own price. Let me take my pen. Look at commodity Y. I follow it. Look at quantity demand of commodity Y and look at price of commodity Y, its own price. What is the relationship between them? The relationship between them is positive. So it does not respect the law of demand. I get it. The relationship between them is positive, so it doesn't even respect the law of demand. So since the relationship between them is positive, you say it's a given good. Okay, it's a what? Given good. So you explain what given goods are. That when price of Y increases, quantity demand of Y also is increasing. Okay, it does not even follow the law of demand, so it's a given good. Hello. Now, question C is asking you that determine the nature of commodity Z in terms of its own price. Now, you come and check the quantity demand of commodity Z. Then you check the price of commodity Z. What is the relationship? The relationship for these two is positive, so it's also giving good. Then you explain, like how I explained the first one. Okay, it's positive relationship, so it's a giving good. Hello. If another question had asked you for commodity X in terms of its own price, look at commodity X and its price. Look at commodity X and its price. What is the relationship between them? It's negative relationship, isn't it? So this one, since it's negative relationship, it follows the law of demand. So you are going to say it's an ordinary good. Okay, it's an ordinary what? Good. Don't forget that. It's an what? Ordinary good. The one that respects the law of demand is ordinary good. Okay, don't forget that. So let's proceed to question D and E. Now, let me erase this place before we go to that. Let me erase what I've written here. Okay. Okay. Question D says, determine the relationship between commodities X and Z. Now, to determine the relationship between them, they want you to tell if it's a substitute or complementary good. Okay. So what you are going to do is that you check commodity. The question asks for X and Z, right? Commodities X and Z. So you go to quantity demand of commodity X. Are you following? When you go there, okay, you go to quantity demand of commodity X. Then you go to price of commodity Z, because you are comparing two commodities X and Z. So you just check the quantity on one equation. You check the quantity demand of commodity X, okay, and the price of commodity Z. What is the relationship between them? There is a positive relationship between them, isn't it? Please write it down. Whenever there is a positive relationship between quantity demand of, let's say, commodity X and price of another commodity, let's say commodity Z, they are substitutes. Hello, please write it down. Commodity X and price of commodity Z, the relationship between them is positive, so they are substitutes. Okay, meaning that when price of this person increases, when price of commodity Z increases, holding commodity price of commodity S constant, the quantity demand of commodity S increase because price of commodity Z has increased. People are leaving commodity Z for X, so it is substitute. Okay, yeah. Then I hope you've written it down. E, determine the relationship between commodity Y and Z. So now, before I go to E, another way of checking Z, X and Z is that you can check this last equation too. QDZ and price of X. Just like how you check QDX and price of Z. You can check QDZ and price of X. It's still positive. Have you seen that? So it's confirmed that your answer is correct. It's still positive. They are still positive. It was positive here. It's still positive here. QDS and PZ. Or you check QDZ and PX. So you can use either of them to check it. Okay. So it's still positive. So they are substitute. Is that clear? So let's go to question E. Question E says, determine the relationship between commodities Y and Z. To do this, I follow. To do this, you look at commodity Y. Have you seen commodity Y? Yeah, quantity demand of commodity Y. Then you look at price of Z. This price of Z. What relationship is between them? It's a negative relationship. Whenever there is a negative relationship between quantity demand of a particular commodity and price of another commodity, when there is a negative relationship, it is complementary good. Okay, it is complementary because this, when the price decreases and the quantity demand of this is increasing, it means that they are complement. That's why the quantity demand of this increase. They are jointly demanded. Are you following? Yeah. You can also check it for this side. Since you are comparing QDY and PZ, you can compare it here by checking QDZ and PY. You see that then the relationship is still negative, so it's complementary good. Is that clear? So that is it. So you have two ways of checking that. Okay. You can replay over and over again. So let's proceed to the next question. This question says evaluate the following summation notation, A and B. So we are going to take them one after the other. Now please pay attention to this. To evaluate this, let's take the solution. A. Let's say I rewrite, let's say in exam I take my question paper and answer booklet, then I write solution. I can rewrite the question, okay, I can rewrite, and the next thing I will do is that, what this means is that since j is equal to 2 up to maximum of 4, it means that wherever you see j, put 2 over there, then you sum them up to 4. So for the first j, for the first one, you repeat this. Wherever you see j, you are going to put 2 there. So you are going to have 2 plus 1 because j plus 1. Then bracket close square. Divided by, here you have 1 plus j square. So it's going to be 1 plus 2 square. Are you following? Plus, then you increase to 3. From 2 to 4. We are going from 2 to 4. Are you following? So you use the same thing. 3 plus 1 square. Divided by 1 plus 3 square. Plus, then the last one is 4. You stop at 4. So 4 plus 1 all square. Divided by what? 1 plus 4 square. Are you following? So that's how you do it. Just substituting. So, and this gives you what? 2 plus 1 is what? 3. Isn't it? 3 square is 9. That's why I wrote the 9 here. 1 plus 2 square. 2 square is 4. So plus 1 is 5. So that becomes 9 over 5. So the whole of this becomes 9 over 5. Isn't it? Then let's go to the second one. 3 plus 1 is what? 4. 4 square is 16. Isn't it? Then 9 square is 3 square is 9 plus 1, 10. That's 16 over 10. Plus, you can use your calculator, okay? 4 plus 1 is 5. 5 square is 25. So you write it. 1 plus 4 square is what? 16. That's 17. So when you add all these together, please check it if I've done a mistake. Add it yourself. 9 over 5 plus 16 over 10 plus 25 over 17 should give you 414 divided by 85. Anyone can do a mistake, so if there is a mistake, correct it. Just make sure you add it properly. Okay. So let's proceed to question B. Question B says, now look at the question B. It has two sigma notations. Okay, so pay attention to this. Now to answer question B, you are going to take this person first. You are going to solve this person separately. After solving this person separately, then you use it in addition with this. That's what we are going to do. So for this, it only talk about j. It didn't talk about I. Okay. There is a typing mistake here. This place should be there is a typing mistake here. Correct this one to I. Change this to I. This. Change it to I. Okay. I, not J. It's I. Okay. Let me go back. So this place should be I. Okay. Correct it to I, not J. Okay. So I. Okay. So we are going to solve this first. So that gives us what? You have the I. Okay. So that gives us, wherever you see J, you are going to be putting 1 there up to 4. So when you take the first function, you have I square, which remains constant, plus 1 square, plus I square again plus 2 square, plus I square again plus 3 square, plus I square again plus 4 square. Okay. Wherever you see J, you'll be putting 1, you'll be putting the values 1 up to 4. That's what you are doing. So the mistake was throughout. Okay, so we are going to have I square plus 1 square is 1, plus I square plus 4, 2 square is 4, plus I square is I square, 3 square is 9, I square here is I square, 4 square is 16, isn't it? So when you add them, I square plus I square plus I square plus I square gives you 4I squares. I getting it? 4I square. Then 1 plus 4 plus 9 is 14 plus 16 is what? Is 30. So you are going to have sigma I equals 1. That's 4I square plus 30. Before you now simplify this also. So that gives you what? 4I square means 4 times I square. So we are going to take 1 to 3. So 4 times 1 square plus 30 plus 4 times 2 square plus 30 plus 4 times 3 square plus 30. Is that it? So 4 times 1 square is 4 plus 30. 2 square is 4, right? 4 times 4, 16 plus 30. 3 square is 9. 9 times 4 is what? 36 plus 30. So when you add them, when you add this and this, you get 34. This and this, you get 46. This and this, you get 66. Then you add everything together, you get what? 146. So that is the final answer for this. So let's quickly look at question 3. Question 3 says, given a two sets of equation 1 and equation 2, where S is savings, I is investment, small I, okay, is interest rate, and all other variables are familiar. Identify the constants as numeric and parametric. B, variables as independent and dependent. C, the coefficients. Now to answer this question, kindly pay attention. To answer A, please, the constants are, listen, the constants are A, B, C, D in equation 1. And in equation 2, the constants are negative 50, 0.3, just 0.3, then 250 and negative 0.2. Okay, those are the constants. Are you following? Now, and the question went further to ask you, say, as numeric and parametric. Now, the ones that are in numbers, okay, are numeric constants. So, for instance, negative 50, 0.3, 250, and negative 0.2 are all numeric constants. They are in numerals. Whereas A, B, C, and D are parametric constants. Okay, yeah. So, they are all constant though, but some of them are numeric and some are what? Parametric. So, you arrange them like that. This, and this are numeric, and A, B, C, D are parametric. Okay, and let's go to question B. Question B says, the variables, we should determine the variables as independent and dependent. So, first of all, what are the variables? This is a variable. QD is a variable. Okay, QS is also another variable. Are you following? P is another variable on its own. P is a variable, as I used here. P is a variable. Are you following? Then Y here is a variable. I here is a variable. Okay, this I2 is a variable. This S2 is a variable. Now, these are the variables. You list them. Then to separate them, to show the ones which are independent and the ones which are dependent. Now, which one is determined by the other? Okay, independent, let's say independent are P, Y, and I. Okay, they are determining the nature of the others. Y is determining saving. Income determines what you save. So, income is independent. I, interest rate determines investment. Have you seen that? So, I is also independent. Price. The price determines quantity demand and quantity supply. Like, the quantity you demand and quantity you supply depends on price. So, since they depend on price, price is independent. Meaning, price is controlling them. Price is determining them. Do you get it? So, price is independent. Y is independent. And small I is independent. Then, dependent are going to be QD, QS, S, and capital I. They are dependent. For them, they are determined by the other person. They are depending on another variable. Okay, so they are dependent variables. QD, QS, S, and capital I. They are dependent variables. Then the last question says the coefficients. Now, you see those constant that are affecting the independent variable. Those constants affecting the independent, they are called coefficients. So b, d, 0.3 and negative 0.2 are coefficients. They are coefficients of the independent variable. So they are called coefficients. Okay, they are called coefficients. If another question had asked you to determine the autonomous constant, the autonomous constants are a, c, negative 50 and 250. They are autonomous. Nothing. They are just constant. Like they are not determined by anything. Okay, they are not affected by any variable. Okay. Yeah. So let's proceed to question 4. Question 4 says, group the economic functions listed below under the following: constant, linear, quadratic, cubic, rational, and exponential function. So to do this simply, let's create some short table. So we put constant functions here, and here we are going to put linear functions. Here we put quadratic functions. Here we put cubic functions. Okay, let me write it C3, cubic. Okay, but you have to write it in full. I'm just summarizing it. I'm just writing it in short. Cubic function. Then here we put rational function. Then here is exponential function. Exponential. Now we are going to group them according to constant, linear, quadratic, cubic, rational, and exponential. So what is average fixed cost? Now, please write it down. Okay. Average fixed cost is a rational function. Okay. Average fixed cost is a rational function. Okay. AFC. Average fixed cost is a what? Rational function. Don't forget that. Okay. So we've answered this one. So marginal product, MP. Marginal product looks like N shape or U shape. N shape, right? So marginal product, whenever you have a curve, N shape or U shape, they are quadratic. Okay, so it's a quadratic function. MP is a quadratic function. MP is quadratic. Okay. Then average cost. Average cost also is quadratic. Okay, so AC. Average cost is also what? Quadratic. Then the next one, population growth rate. Population growth rate is exponential. Okay, it's exponential. Okay, population growth rate. Let me write it PGR. Population growth rate is exponential. Now we have two types of population. We have exponential population growth rate, and we have logistics population growth rate. The logistic one looks like a cubic function, but don't take your mind to that one now. For this question, they are expecting the answer exponential function from you. Okay. Then total fixed cost. Total fixed cost. The total fixed cost is constant, so it's a constant function. Okay. The total fixed cost, TFC, is a constant function. I follow. Then the next one, average variable cost. Average variable cost. Average variable cost is quadratic. Okay. Average variable cost is quadratic. Write it down. Average variable cost is quadratic. Then interest rate. Interest rate is also exponential. Okay. Let me write it small I. Interest rate is also exponential. Okay. Then the next one, total variable cost. Total variable cost. Right? Now, total variable cost is a cubic function. Okay. Total variable cost is cubic. TVC. Because it looks like this. It has two turning points. It has two turning points. Okay. So, since it has two turning points, it's a cubic function. You can check it out. Look for the image, like the graph. You see that TVC has two turning points. So, it's a cubic function. As for quadratic function, they only have one turning point. But cubic functions have two turning points. Have you seen that? Yeah, so. Then, let's go to the next one. Marginal cost. marginal cost, MC. Marginal cost is also quadratic. Okay, marginal cost is also quadratic. Then the next one, consumption. Consumption function is a linear function. Okay, consumption is what? Linear. You see, consumption will be like C is equal to A plus BY or BYD. You see something like that. It's a linear function. Okay, it's linear. Consumption is linear. Then total product. Now, total product is cubic function. It also has two turning points. Okay, total product is cubic. Okay, then the next one, investment. Investment is also a constant function. Investment is constant. Okay, there are times if investment is depending on interest rate. Okay, it can be a linear function at times. Okay, but I think here they are expecting you to say investment is constant. Okay, but at times investment can be a linear function. Okay, we did something here. Here, look at investment. Have you seen that it's a linear? It's a negative curve. It's a negative line. Have you seen it's linear because it's depending on interest rates. It's linear over here, but you consider it to be constant in answering this question. Okay, then total cost. Total cost is cubic. Okay, total cost is what? Is cubic. Total cost is cubic. Then we have average product. Average product is quadratic. Okay, average product is what? Is quadratic. Average product is quadratic. Okay, so that's the end of this. So kindly write them down, then you revise it. Okay, and you look at the shape, how the curves look like in the equation, then you use it to remember. Okay, so let's proceed to the question 5. Question 5 says, from the following logical statement, indicate whether they are true or false. A, x squared is a member of Z and implies x is a member of Z. Now, this Z stands for integers. Are you following? The Z stands for what? Integers. Z is a symbol for writing integers. Okay, so we are saying that if x squared is a member of Z and it implies that x is a member of Z. Let's try it and see. Let's take square root of 5, for example. Square root of 5. Square root of 5. Square root of 5. Let's assume x is square root of 5. Okay, so square root of 5 square gives you what? Square root of 5 square gives you 5, right? This square cancels this square root, so it gives you 5. So meaning x squared, considering x as square root of 5, x squared is an integer. But x alone doesn't imply that x itself is also an integer. Square root of 5, is it an integer? Square root of 5 is not an integer. Is it an integer? No. So since it is not an integer, then the answer is false. Okay, so the answer for A is false. I follow it. Yeah. So it's not always true. Then let's take the second one. X plus y is equal to 7 implies x is equal to 2 and y is equal to 5, and this also implies x plus y is equal to 7. Is that true? Look at the symbol I've used here. Equivalence. Okay, is it always true that when x plus y is equal to 7, then x must be 2 and y must be 5? Now take a look at something. If x is 2 and y is 5, definitely x plus y will be equal to 7. So when you were going like this, it was true. When you were going this direction, it was true. If x is equal to 2 and y is equal to 5, definitely x plus y will be 7. But when you are coming like this, is it always true? So let's check it. You know, 3 plus 4 can also give you 7. So x plus y equals 7 does not necessarily mean x is equal to 2 and y is equal to 5. It could be that x is equal to 3 and y is equal to 4. It could be that x is equal to 1 and y is equal to 6. It could also be that x is equal to 6 and y is equal to 1. So this is always not true. Okay, This is always this direction was true, but this direction was not always true. So since both conditions do not hold at the same time together, the answer for this is false. Okay, so the answer for this is false. This is also false. Let's look at this. Question C says xy is even implies x and y are both even numbers. Is that true? Let's check. Let's assume let's take 2 and 3. Okay, 2 times 3 gives you what? 6. Is 6 not an even number? But 2 is an even number and 3 is not an even number. So it does not always implies that. So it's also false. It's also false. I follow. X, y. Let's take x to be 2 and y to be 3. So 2 times 3 is 6. So it's even. But 2 is even and y is not even because y is 3. It's not an even number. So it means that x and y are both not even. So it's not true. This is also false. This is also false. Okay. Then D. D says x is an isosceles triangle. Implies x has 2 of each side equal. Is that true? This implies this. Now, whenever a triangle is an isosceles triangle, it implies that 2 of each sides are equal. In fact, 2 angles are also equal. Isn't it? So this is true. This implication is true. This implication is true. Is that clear? Yeah. So let's look at this. It's like giving a national income determination model as this. Equation 1 to 4, where Y is income, C is consumption expenditure, I is investment expenditure, G is government spending, S is export, and M is import, and R is real interest rate. List down the endogenous variables and list down the exogenous variables. To do this, I follow the endogenous variables. Now, what are endogenous variables? We say endogenous variables in an economic model, okay? Endogenous variable is a variable whose value is determined by the model. The value is what? Determined by the model. I follow it. That's endogenous variable. Okay. Whereas exogenous variables, write it down. Exogenous variables are variables whose value is determined outside the model. Outside. And is imposed on the model. It's imposed on it. Okay. Let's look at how this works. Now, to list the endogenous variables, I follow it. And endogenous variables are y. I'll list them and explain why they are. Then C is an endogenous variable. M is an endogenous variable. Then capital I is an endogenous variable. Now, the reason they are endogenous variable is that when you listen to the definition, you say endogenous variables or endogenous variables is a variable whose value is determined by the model. Now, look at this y. You found y here by summing c plus I plus g plus x minus m to get y. Before you use it here to find what? Consumption, isn't it? Meaning it is determined within the model. You didn't impose this y from outside the model. It is still determined within the model. We found y here and it was input and consumption and here. So it is endogenous. Okay, it can be found within, okay, the model. I follow it. Then C2, you found consumption by this, by saying autonomous plus by, isn't it? To get consumption before you fix it in this model. So you didn't bring it from outside. It was found within the model. You get the answer for C before it was fixed into this function. So you didn't impose it from outside. Are you getting it? So that makes it endogenous variable as well. M2, this is how you found M. M is equal to MO plus MY. It was gotten within the model before it was fixed into this function. Are you getting it? So it is also endogenous variable. Then the I2 is endogenous. Okay. I2 is endogenous. But which ones are the exogenous variables? We say the exogenous variables are, or is the one whose value is determined outside the model and is imposed on the model. So look at x. Look at x. Do you know where x is coming from? No, it was just imposed on the model, right? X is imposed on the model. Then which one again? G. You don't know where the G is not within the model, right? It was imposed on the model, right? Now look at R, real interest rate. It's also imposed on the model. There is no special function for it. You don't know where it was gotten from before imposed on this. So G, X, and R are imposed on the model. In this model, okay, so G is exogenous, X is exogenous, and R is exogenous. Okay, just make sure you understand. The fact that G is exogenous in this question does not mean that in another question G will be exogenous again. It might happen that in another question G will be endogenous. You just have to check properly. Okay, so that's it. So this is a logarithm question for you to solve. So what you are going to do is that you are going to simplify it. Okay, so that will give you what? You know, according to the law of indices, when you have AB in brackets square, it can give you A square B square, right? So this one you can expand it to become x squared times y squared times z squared. This. Then this one also becomes, now according to the law of indices, when you have A exponent 3 into bracket exponent 4, it should give you A exponent 3 times 4, isn't it? Yeah, so you apply same thing here. So this one become x exponent 3 times 4, like what I did here, x exponent 3 times 4. Please be writing your exponent very well. Don't let it look like a whole number like this. Then times y exponent 4. The exponent affect the two of them. Are you getting it? Divided by, so x exponent 5, z exponent 5. So that gives you what? Now what you are going to do here is that, you know, x squared give you 3 times 4 gives you 12. Now, according to one of the principles or laws of indices, you learned that when you are multiplying something that have the same base, you add the exponent, isn't it? So we are multiplying x squared and x exponent 12. You should get x exponent 2 plus 12, isn't it? You should get x exponent 2 plus 12. Also, y squared times y exponent 4 should give you y exponent 2 plus 4. When you are multiplying same base, you should add the exponent, isn't it? Times z squared. The z squared is not having any other z, so you repeat it. Divided by this. Now, that gives you x exponent 14 times y exponent 6 times z exponent 2 all over x exponent 5, z exponent 5, isn't it? So that gives you what? Now, for division too, when you are dividing two things that have the same variable, okay, they have the same base, sorry. When you are dividing same base, you should subtract the exponent. So x exponent 14 divided by x exponent 5 gives you what? X exponent 14 minus 5 times, the y is not having any denominator, so you repeat it, y exponent 6 times, then z exponent 2 divided by z exponent 5 should give you z exponent 2 minus 5. Are you following? So that gives you x exponent 9 times y exponent 6, okay, all divided by z exponent 3. The reason is, you know, z exponent 2 minus 5 will give you z exponent negative 3, okay, and you can convert it to division, okay. So that is the end of this. So thank you for watching. We'll take we'll take another question in another video, okay. So have a nice day.